Welcome to Midnight Index. There comes a point in life when you realize you have no idea how half the stuff around you actually works. I hit 25, now 30, and suddenly, I was too embarrassed to admit I didn't know why stoplights change, how my phone connects to the internet, or why we still make pennies when they literally cost more than they're worth. So I finally looked it all up. Here are 10 things I was too afraid to ask after I turned 25 but really should have. Let's get into it. 1. How do they put an M on each M&M? You might think there's some tiny elf factory meticulously stamping each candy, but the real process is a lot more industrial, though still just as fascinating. The secret lies in offset printing, the same technique used to print newspapers. Here's how it works. The M&Ms are placed on a conveyor belt in perfectly lined up rows. A machine holds a rubber stamp that's covered in edible white ink, but instead of pressing directly onto the candy, the stamp first applies the ink to a flexible printing drum. This drum then rolls over the M&Ms, applying thousands of tiny, perfectly placed M's in just seconds. Think of it like a temporary tattoo for candy. Instead of pressing the ink directly, the machine transfers it from one surface to another, ensuring each M is printed just right, without smudging or missing its mark. And if you've ever seen an M&M without a logo, that means it probably bounced out of place before it reached the stamp. Quality control catches most of them, but occasionally, a rogue blank one makes it into the bag. 2. How do TVs actually work? Can I touch a pixel? If you've ever been curious about what makes a TV screen come to life, the short answer is millions of microscopic light bulbs. But the full story is way cooler than that. Modern TVs work using either LCD, liquid crystal display, or OLED, organic light emitting diode, technology. Let's break it down. LCD screens have a backlight, essentially, a bright white light that shines through a grid of tiny, color-changing liquid crystals. Each of these crystals acts like a little gate, blocking or allowing light to pass through in different intensities of red, green, and blue. When combined, they create the millions of colors you see on screen. OLED, on the other hand, doesn't need a backlight. Instead, every single pixel is a self-lit, microscopic organic diode. This allows for deeper blacks and more vibrant colors because when an OLED pixel is off, it's completely off, no backlight bleeding through. Now, the real question, can you touch a pixel? Theoretically, yes, but practically, not really. A pixel is so small that even if you pressed your finger against the screen, you'd be covering thousands of them at once. If you want to see a pixel up close, grab a magnifying glass and look at your TV from just a few inches away. You'll see the tiny red, green, and blue subpixels that combine to form a single point of color. And if you've ever noticed a single dot on your screen that never changes color, congratulations, you've just found a stuck pixel. These can sometimes be fixed by flashing rapidly changing colors over them, essentially unsticking them at a microscopic level. 3. How do digital cameras work? Imagine your eyes taking a picture, but instead of using a brain to process the image, it's all done with millions of tiny light sensors. That's essentially how digital cameras work. At the heart of every digital camera is a sensor, either a CMOS, complementary metal oxide semiconductor, or a CCD, charge-coupled device. When light enters the camera through the lens, it hits this sensor, which is covered in millions of microscopic photosites, each acting like a tiny bucket, collecting light particles called photons. Each of these tiny light buckets records how much light it received and converts it into an electrical signal. But here's the thing, these sensors don't actually see color. They only detect brightness. So how do we get color images? Enter the Bayer filter, a grid of tiny red, green, and blue filters placed over the sensor. Each pixel captures just one of these colors, and the camera's processor then interpolates, or guesses, the missing colors based on surrounding pixels. This process is called demosaicing, and it's why digital cameras can produce full color images. Think of it like a mosaic tile floor. Each tile is only one color, but when you step back, they form a complete, colorful image. Finally, the camera's processor takes this raw data, sharpens it, corrects colors, and compresses it into a file like a JPEG or RAW so you can view and share it. 4. How do stoplights work? Stoplights simple on the outside, but on the inside? A whole system of sensors, timers, and algorithms working together to keep traffic flowing. Most modern stoplights use 3 main control methods. Fixed timers, these operate on a schedule, changing lights at set intervals, useful in places where traffic is predictable, like small towns. Inductive loop sensors, ever notice those rectangular lines cut into the pavement at intersections? Those are inductive loop sensors, which detect when a car is waiting by measuring disruptions in an electromagnetic field. Adaptive systems, Some cities use AI-driven traffic lights that analyze live traffic data from cameras and sensors, adjusting signal timing in real time. So, if you've ever wondered why you're stuck at a red light when no one's around, you're likely dealing with a fixed timer system or a broken sensor. But what about emergency vehicles that seem to change stoplights at will? That's preemption technology. Many fire trucks and ambulances have a special infrared transmitter that sends a signal to a sensor near the traffic light, forcing it to change green in their favor. And if you've ever tried pressing that walk button at an intersection, wondering if it actually does anything, well, sometimes it does. But in many modern cities, they're placebo buttons originally functional but now disconnected, left in place to make pedestrians feel like they have control. 5. How does wireless internet and phone service work? If you've ever wondered how your phone magically connects to the internet without cables, the answer is radio waves and an invisible network of towers, routers, and satellites working in sync. Think of it like this. Your phone is a tiny radio station, constantly sending and receiving data. When you make a call, send a text, or browse the web, your phone converts your voice or data into electromagnetic waves and transmits them to the nearest cell tower. These towers are everywhere, hidden on rooftops, disguised as trees, or standing tall in open fields. From there, the signal is sent through fiber optic cables or microwave links to a massive infrastructure of network centers. If you're calling someone nearby, the data is routed to a tower near them, then converted back into sound or text on their phone. If they're far away, the signal might travel through an undersea cable or even bounce off a satellite in space before reaching them. And Wi-Fi? It's similar, but more localized. Your router is like a mini cell tower for your home, using radio waves to transmit internet data between your devices and your internet service provider. Ever noticed how your phone switches between LTE, 5G, or Wi-Fi? That's because your device is constantly searching for the fastest and strongest signal, and if one network gets too crowded, your phone will hop to another to keep things running smoothly. 6. How do you defog the windows in your car when it rains? It's one of life's small but frustrating mysteries. You're driving, it starts raining, and suddenly your windows fog up, making it impossible to see. Why does this happen, and how do you fix it? Foggy windows are caused by condensation, which happens when warm, humid air inside your car meets the cold glass of your windshield. The temperature difference makes moisture in the air turn into tiny water droplets, just like a cold soda can sweating on a hot day. Here's how to fix it. Use your car's defroster. Turn on the front and rear defrost settings. These use hot air or electric heating elements to warm the glass and evaporate the condensation. Turn on the AC. This might sound counterintuitive, but air conditioning removes moisture from the air, helping to clear the fog faster. Crack a window. Letting outside air in helps balance the humidity inside your car, reducing condensation. Use the air recirculation button wisely. Turning it off allows fresh air from outside to replace the humid air inside, which can speed up defogging. And if your windows keep fogging up frequently, a hydrophobic anti-fog treatment like the kind used on swimming goggles can make a big difference. 7. How did they mass-produce ballpoint pens early on? Ballpoint pens are everywhere today, but when they were first introduced, making them in large quantities was a serious challenge. The trickiest part? Getting the ink to flow smoothly without leaking or clogging. The solution came from precision engineering. Tiny metal balls, usually made of steel or tungsten carbide, were inserted into the pen tip with extreme accuracy. These balls roll freely, picking up ink from the reservoir inside the pen and spreading it evenly onto the paper. But how did they make these pens fast? Automated assembly lines. Factories developed machines that could press-fit the tiny ball into the tip, ensuring a snug fit without the need for glue or welding. Injection molding. Plastic pen barrels were mass-produced using high-speed injection molding, allowing millions of identical casings to be created quickly and cheaply. Quick-drying ink. Early ballpoint pens struggled with ink drying too fast inside the pen or too slow on paper. Manufacturers refined oil-based ink formulas that would dry at just the right speed, preventing smudging while ensuring the ink wouldn't clog the tiny ball. Think of it like a rolling paintbrush. The ball picks up ink, spreads it, and constantly rotates to refresh the supply. This mass production method was perfected in the 1940s, thanks to Laszlo Biro, the inventor who turned the ballpoint pen into the go-to writing tool we use today. 8. Why don't they make tires or an alternative that doesn't wear down? If we can make bulletproof glass and self-healing materials, why are we still replacing tires every few years? Wouldn't it be better if tires never wore out? The short answer: it's complicated. Tires need to balance three things: grip, durability, and ride comfort. The rubber compound used in tires is specifically designed to provide enough friction to keep your car from sliding all over the road, but that friction is what causes them to wear down over time. Here's why making a forever tire is tricky. Too hard equals no grip. If we made tires out of ultra-durable materials like solid metal or ceramic, they'd last much longer, but they wouldn't grip the road well, making driving incredibly dangerous. Too soft equals wears out faster. A softer tire gives better traction but wears out quickly. Racing tires, for example, can last as little as one race because they're designed for maximum grip. Self-repairing tires exist, but researchers are developing self-healing rubber that can repair small punctures, but the tread will still wear away over time. Michelin has been working on airless, 3D printed tires that never go flat and last much longer, but we're still a ways off from a tire that never wears down. Until then, rotating your tires and maintaining proper air pressure is the best way to extend their life. 9. Why do we, the United States, keep making pennies when it costs more to make one than they're worth? It seems completely backwards. Why would we keep producing something that costs more to make than its actual value? As of recent years, it costs about 2.5 cents to make a single penny. That's more than double its face value. So why hasn't the US just gotten rid of them? The biggest reasons are: people don't like change. Or rather, they do. The penny has been around since 1793, and a lot of people argue that eliminating it would disrupt pricing, cash transactions, and even traditions, like tossing pennies into fountains. Rounding concerns. Without pennies, businesses would have to round prices to the nearest nickel. Some fear this could cause rounding inflation, where companies always round up, subtly increasing prices. Lobbying by the zinc industry. Pennies today aren't solid copper. They're actually 97.5% zinc, with a thin copper coating. Companies that mine and process zinc have a financial interest in keeping the penny alive, and they actively lobby Congress to prevent its elimination. Several countries, like Canada and Australia, have already phased out their smallest coins without issue. But in the US, the penny remains more of a political and emotional debate than an economic one. Until a major shift happens, pennies will keep costing more than they're worth, literally. 10. How are towns and roads named? Ever driven through a place with a bizarre name and wondered, who came up with that? The names of towns, streets, and highways don't just appear out of nowhere. They follow patterns based on history, geography, and even politics. Here's how it typically works. Named after people. Many cities and roads are named after founders, presidents, or historical figures. Washington, D.C., named after George Washington. Lincoln, Nebraska, named after Abraham Lincoln. Geographic features. Some places are named based on landscape and nature. Think of Boulder, Colorado, for its rocky terrain, or Jacksonville, Florida, for its proximity to the St. Johns River. Native American influence. Many town names come from indigenous languages, like Chicago, from a Miami, Illinois word for wild onion, or Seattle, named after Chief Saul of the Duwamish and Suquamish tribes. Road names follow patterns. Streets in grid-style cities often follow simple naming conventions. Some use numbers, like 1st, 2nd, 3rd Street, while others use themes, trees, states, presidents. For example, Manhattan streets run in a numbered grid, while Washington, D.C. organizes them alphabetically. Random or funny stories. Sometimes, places get their names from odd local events. For example, there's a town in Texas called Cut and Shoot, supposedly named after a heated church dispute that almost led to violence. And in Pennsylvania, there's a town literally called Intercourse, named after an old term for social interaction. Even modern roadways follow strict rules. Highways in the U.S. use a numbering system. Odd-numbered highways run north-south, while even-numbered ones run east-west. Next time you're driving past a weirdly named place, remember there's probably a story behind it. So, am I the only one who didn't know these things? Or are we all just out here pretending? At least now we've got answers. Turns out, it's never too late to learn the stuff you should have been taught in the first place. If you found yourself nodding along, hit that like button. And if you never want to feel out of the loop again, consider subscribing, because there's a whole world of everyday mysteries out there, and I'm still catching up. Until next time, stay curious.